Okay, we're going to move to a new topic. But this is topic, surprisingly, I mean, this is maybe exception. Some of you might learn the concept of exception by other programming language. But it's interesting. We're going to talk about exception in object-oriented language, and yet you will realize it is interfering with the concept we just learned in chapter 14. So it's really interesting, chapter 14 and chapter 15. One is multiple inheritance. Particularly, we covered one of the most challenging concept, which is called polymorphism, in chapter 14. And when we will be going over chapter 15, you will realize that polymorphism is still making impact in the space of exception. Okay, so I'm going to just cover a little bit inheritance, and before I jump to exception, I just want to ask you this question. The reason you can think about this is maybe a sample final exam question. So I will show you this piece of code. This actually, sorry, is not piece of code. It's basically just a piece of code, and then you try to compile it. This is, by the way, one of your homework assignment number 0 kind of situation. By the way, this code is there in the exception GitHub link as well. So some of you actually saw this particular error message. Have anybody see this kind of error message, like a starter with S and then parentheses, HTTP server, this kind of thing? And so if you never seen that, that's fine. But I want you to try to read the whole yellow portion. Try to figure out if you see like an error message or warning message. I mean, by the way, this is error message. So the compiler is going to provide us some information. So I want to ask you to kind of try to comprehend the yellow part of the message, and what does it tell us? Anyone? Try to look at just the yellow part. What kind of, yes?
This reminds me of abstract classes from Java. Like it's requiring some method to be defined in an inherited class, I think.
Okay, good. That's the right answer. It basically says that it's expecting you actually define certain method within the class, which is typically a subclass inheriting from a parent class, and then essentially you didn't, and therefore you actually have that. But there is one particular thing that I want to show you. That look at this part. This part is saying that what do you think? Which one is the what do I call the server? The class that's actually base. In the base class, what does this mean? If I declare a virtual JSON value dumped to JSON and with a bunch of parameter, and then I actually have an equal to 0 semicolon. What does this mean? Why I'm actually declare a member function, and yet I actually put an equal to 0. What does that mean? Anyone except you? You already answered. Anybody want to provide a guess? What is there is a technical term. I forgot. I mean, the reason is I might have forgot to tell you about this, and then when I made up the final, oh, I'm sorry, I shouldn't say that. Yeah, I just want to double check. Okay, what does that mean when I put an equal to 0? Yeah. No, it's not function pointer. It's a good guess. It's a this is what we call. You want to say something? Not exactly. This is what we call pure virtual function. So pure virtual function is essentially saying that I am a base class, and maybe I'm just an abstract base class. So the difference between base class and abstract base class is that the base class, you might create object. But if this is an abstract class, then I'm not supposed to create my own object. I just want to provide a template and allow all the derived class to create. And therefore, this method, if I put an equal 0, that means this is a pure virtual function. Means that I'm expecting everybody inheriting from me is going to have an implementation of this function, except me. So that's why if the right class forgot to declare and implement dump to JSON. More important is actually about declare. You have to declare at the derived class. If you didn't do that, then essentially you will get this kind of compiler error. This is a compiler error saying that, hey, this one is an abstract class, but you. So let me show you the code that corresponding to that. By the way, this code is under the exception folder of GitHub. So if you take a look at this code is I know what to do. I have to make. I cleaned it already. So this particular .h file is being generated by the JSON RPC. So this particular code is in mobility server .h. Let's take a look at this code. So by the way, this code is actually generated. At this stage, I actually hope that you feel comfortable to at least try to read the code that's actually generated. Sometimes you will learn generated code, learn more from the generated C++ code than the code handwritten, because the code that's automatically generated is actually a well-designed platform. They know what they're doing. That's why they actually produce this kind of code every day. And then they produce million lines of code like this process. So code generation like this, I'm not talking about generating machine code. I'm talking about you use some kind of specification language to generate C++ code, or maybe generate Python code, whatever. So this code was generated. You can see that I defined something called mobility server here in this .h file. But you can see that this is inheriting from JSON RPC. This is an abstract class, abstract server, which is a template based on mobility server. This is actually a template class, but it's a base class. But under the mobility server, take a look at here. All the method, I only have a send and dump to JSON. I only have a 2 method, and both of them are equal to 0. Means that I actually define 2 virtual functions. Both of them are pure virtual, and therefore, whoever inheriting from this generated code has to implement those 2. So let's actually take a look. Who actually inheriting them is actually mobility server.cpp. So mobility server.cpp was also included. And if you take a look at this code, I actually create a server called my mobility server. I actually inheriting from that code, which is mobility underscore server generated by JSON RPC. Sorry, that was called mobility underscore server.h. And take a look at this. I actually purposely, in order for me to generate that error message, I purposely block this line of code. So you can see what this line, the code, I just block it using the macro, is the real declaration for that function that was a pure virtual function in my parent class. So this one, because this will cause error because you forgot to actually include that. Okay, so that is number one. I want to make sure everybody understand the concept about pure virtual function, especially you understand the example that we included here. Okay, that's number one I want to cover. Okay, number two, I'm actually going to talk about something called type ID. Okay, so type ID is an operator in C++. By the way, I actually don't know whether you have type ID in Python or Java. Do you have any Java programmer here knowing that you have type ID? Yes?
They have it in Python.
They have it in Python. So type ID is in Python. So what is type ID in Python?
It gives you back the class that object, like in runtime.
Okay, okay, good. That's a good one. So why do I need to know the type of an object at runtime? I mean, I'm a programmer, right? I mean, of course, I wrote my code. I should know the class. And why do I need to know the class of an object at runtime? Why do I need to do that? I mean, this apparently has a need, means that I actually don't know the class of a particular, the type of a particular object, right? That's why I need type ID. So any kind of particular scenario you have seen recently? Yes.
Yeah, in game engines, if you have like a bunch of objects in a row, you might want like a person versus like an animal, but those might be inherited from like the animal class. So like
this is a casting. In fact, it's not only casting, it could be polymorphism.
Yeah.
Right. I want to essentially this is related to polymorphism because in when you have this kind of casting, when you have like a multiple level of object, especially either use polymorphism or you use reference and casting, then essentially you lost your original class, means the class you were created. Which class you were created, you might not know at certain point of the code. And therefore, the type ID is a very useful operator for us to do that. So I'm going to show you a piece of code. This is, by the way, is important, and it actually start to touching on the some of the topic exception. Okay, this will lead to exception. So I'm going to show you this piece of code. I have a two pair of base class and derived class. So the first one is called NP. The second one is called PL. What's the difference between these two pairs? So there are two pairs. The first pair is NP base and NP derived. The second pair is PL base and PL derived. What's the difference between these two pairs? Anybody? We have been getting answer from this side. How about on the other side? Anybody? I mean, don't worry about answer wrong. I mean, that if you don't know, that's perfectly okay. Yeah. It's declare a virtual function. Remember, we say whenever you declare a virtual function, this became you have a V table, which means that this becomes a virtualization. Become a virtual relationship between. So essentially it's two pair. The first pair is a non-polymorphism. That's why is NP is non-polymorphism because it doesn't have V table. But the second one, the second pair is actually polymorphism. That's why I call it PL. So now we have NP pair and then we have a PL pair. Okay, so now let me actually show you a piece of code. I mean, I want you to guess what's the code generated. So you can see that this line, I actually create an object called NPD. And then you can see here, I actually casting NPD to NPB. So what's this is base. So now this is two objects. They're not inheriting each other with polymorphism. They're just regular, okay? So I one of the effect I want to achieve this at this moment is make sure you hate polymorphism. Okay, I'm just kidding, but it's really complicated. I'm getting more and more complicated this way. So this is a non-polymorphism, looks like that. Okay, a pair NPD, and then you kind of use object class reference to actually casting that object into a NPB. You're casting your derived to a base. It's called by reference. Okay, it's a reference. And then basically I said I print this one. Look at what I print. I print NPB.name. I print NPB, which is the one that's actually I casting into. And I print using type ID with this object and .name. By the way, this is the syntax of the operator type ID. So type ID take an object or a class or some of the type and go in here and then say dot name. It's actually going to print the name of the class. Okay, more or less, I'm going to show you some examples. Sometimes it's not exactly print the class name you expect, but it's close to that. So this is one name that's actually printed. And then the second one, you can see that I have another pair, PLD and then PLB, the same thing. I'm doing casting from the derived to the base using reference, but except this time, their relationship is polymorphic. And then I'm doing the same thing. I do a type ID PLB dot name like this. Okay, so I'm going to give you a hint. You're actually going to see somewhat different style of output from this two line. What do you think you're going to get? Let's try to run the program. Okay, this program I actually put it, let me see, what do I have here? So today you can really just, after you heard this, you can actually go back to try this yourself. So I believe this one is G++ minus std equal to C++ 14, and then this is type ID test. Okay, so now let's try to run it. Okay, so you only look at the first two lines and don't look at the second line and third line. We have, the third lines and fourth line. Just look at the first two lines. That's what we have covered so far. So you can see that what's the class name it print? For the first case is actually print a number 7, which is actually platform dependent about what should be that number. So that's why I said it's not printing exactly the class name. It's some kind of class name plus something else, such as a number. And the first one is actually printing NP base. It's printing NP base. And the second line is actually printing PL derived. Okay, right? So now let's go back to the code. So what I'm saying is this line is actually printing NP base. And this line is actually printing PL derived. Okay, so it's a type ID is helping me using the syntax. You just put this object into only argument of the operator, and then the whole function you return, actually the function return an object called type info. By the way, I skipped that. You see that at the first line, I actually include type info. So type info is an include file provided by C++ standard library. Inside there, if you find an object called type info, it has a class called type info. And one of the member function of the type info is name. That's why you see that type ID this, and then .name, which is actually give you the name. But what's interesting is that the first one is actually give you what? The result of the assignment or whatever casting if they are not polymorphic. But if you're polymorphic, then I'm actually going to give you the original class name when the object was created. Okay, even you casting with a reference. So okay, so now I want to tell you that type info is useful in order to get exactly the object that was the type of the object that was at the moment it was created. Then essentially you have to you have to have some perspective of virtualization in your system. Okay, so that's basically some of the trick you should learn. I mean, again, this is polymorphism. This is some of the information about the class hierarchy. Any question? Good. Okay, great. All right. If you have any question, let me know. But now I'm actually going to do a little bit more. I'm actually going to, the first 4 line, I kind of repeat from the previous page. That's basically 2 pair of class. The first pair is non-polymorphic, base derived. The second pair is polymorphic, base and derived as well. So now let's actually look at the 3 line. Look at what I did. This is related to what we talk about. Try to use a 0 address to derive the offset. And this is kind of similar style. So take a look at what's here. I'm actually setting the NP derived, NP back pointer. I'm actually setting to be null. So it's a null pointer to a NP derived. And let's actually see what I did here. In this line, it's kind of strange. I kind of, this is called dereference, right? So this is a pointer. What kind of pointer is this? This is a null pointer, okay? And then I try to do what? Do dereference. So what do you think if I dereference a null pointer is going to, what's going to happen? Segmentation fault. I thought it was segmentation. I'm sorry, it's not today. All right, so segmentation fault is taking a vacation when Felix and the ecs36b student decide that they should take vacation. Of course, I'm joking. All right, so there was a reason when we talk about polymorphism, when we talk about type ID, this is another exception that it will not cause segmentation fault, but it caused something else, okay? So you can see that over here, I actually have a non-polymorphic pointer, null pointer, and I do type ID. I try to dereference a null pointer and got the name. What do I get? I will show you. And then I'm interesting is now it's polymorphic. Everything else is the same, but I'm actually using that polymorphic pointer, and basically I set it to null. And again, I dereference a null pointer and try to get type ID and then get name. Okay, what will I get? Okay, let's try to run the program. Actually, I'll just show you the result, but you probably didn't pay attention. So now you see that this 2 line is the next 2 line. Neither of them is actually segmentation fault. Neither of them is segmentation fault. But look at the first line. The first one, if it's the non-polymorphic, the operator type ID will still give you the right type. It gives you 10 NP derived. Basically, NP derived plus an integer in front of that. Okay, don't ask me. I still cannot figure out why sometimes it's 7, sometimes 10, sometimes 9. It has to do with whatever compiler you're using. But if this is the polymorphic, and I did the same thing, guess what I have? This is a cut, std : bad underscore type ID. So that's what? That's actually exceptional handling. So in C++, let me actually write the other program to tell you what's going on. Let me see. I have a program called sectest. Let me see what I have. Oh, great. Let me show you what this program is. This program basically defines a pointer P, and then I assign the P to be null. Okay, I assign this to be null, and then I basically print the dereference of this pointer, and what will happen if I compile this code? Okay, it's definitely I'm going to get segmentation fault because I'm trying to dereference a null pointer, right? So this is if you're going to get the segmentation fault. This is what you get. So the example I show you, the first case, is actually doesn't even produce incorrect result. It was producing the right result. But the second one is not it also didn't give me segmentation for 11. What it gave me is a STD bad type, I think, bad type ID or something like that. So it means that is a particular unexpected condition of the programming language, which actually need to be dealt with. That's why we need to teach you about exceptional handling in C++. So I do want to clarify, just keep this in mind. There are two kinds of situations that's actually runtime error in our system, at least two kinds. The one kind is actually introduced, it was actually caught by the system. The system usually is either operating system or the hardware. It's outside of your program. That's actually something happened. So when that happens, you're going to get segmentation fault. But if this error or some kind of problem was caught within the program itself, within the program, it could be your own program, or it could be whoever wrote the library. That's actually, they actually check certain condition. And if you have a unexpected condition or error condition that was within your own program, including those library you include, then those things are, we consider the exception, then exceptional handling can actually deal with that. Okay, so I want to tell you that. So in other words, I want to tell you, for example, if you have a segmentation fault, then the exceptional handling in C++ is not going to help you to catch this in general. Okay, unless you really did a lot of very dangerous moves in your own program, which is usually not recommended. Okay, so let me actually take a look, tell you that what is exceptional handling. So exceptional handling looks like this. So exceptional handling in the syntax, there are three keywords. One is throw, one is try, one is throw, another one is catch. So try basically define the boundary of piece of code that within this code, you might be able to generate some exceptional condition that's going to be catched by the what we call catch clause right after. Okay, I mean, right now I'm just giving you one try clause, one catch, but you could have a one try with multiple catch, which I will show you a bit later. And the thing is that throw is a command in your program. It's going to throw at a typed object. It could be a typed object or just a data type. For example, you can throw an integer, or you can throw a object RPC, JSON RPC exception, or you can throw a mobility underscore server. You can throw any kind of object you would like to throw. So when you throw it, then the capture has to have the type. They are either matching that type, or it's actually might be polymorphic to that type. So it's either that is exactly my type, or actually that particular type is actually derived from my class. Okay, so that's basically, for example, you can say throw PL derived, and here you can say PL derived, but you can also say throw PL derived, and here you say catch PL base. That's okay as well. Okay, so as long as they type match, just pretty much like the function call, then this is the way it works. So essentially what it does, yeah.
Also, can you use type ID here to then check specifically what exception was thrown? Like if you have like a base class exception.
I didn't get that. Could you try again?
Yes, I will show you that example. Yeah, if I understand what you're saying. But there are multiple ways the type ID can be used here, but I'll get to one example. Okay, so thank you. Any other question? Okay, so let me tell you that what's the flow. The flow looks like this. So you're executing your program over here. For some reason that you actually throw this. And then basically when you throw, then essentially you hit that throw statement, then your program will not continue. Your program will immediately transfers control to catch. And then the catch finish, then the next statement after you finish the catch is basically here. Okay, so it's directly from here, jump to here, if it match, and then jump to whatever after the try clause event. One little detail I want to say is that sometime within the try clause, the throw statement might not be immediately at the first level. So for example, in the try clause, you call another function, and within that function, they can set up a throw such that that particular function doesn't actually catch it. So therefore, you actually at the outside of that function, you have that try clause set up that you can catch it. Okay, so that's very flexible. I'm giving you the most simple scenario, but this scenario could be really powerful for you to handle all kinds of situations. So essentially what we did is like this. So essentially there are 3 steps. The first step is what we call detection. So you usually, when you want to throw something, you must detect some condition for you to trigger the send. So how do you do detection is purely programmer's decision. Programmer is going to decide when I'm going to actually generate the throw statement. And then when you do the throw, you're basically out of your original flowchart, and then you actually transfer your control into catch. And then, of course, when you do the catch, you actually will pass in some argument, which then allow the catch to be able to handle that situation. One of the important things about the difference between traditional programming and exceptional handling, there is no return. When you make a function call, you tend to say, okay, I'm going back to the point which I actually exit. No, in exceptional handling, once you exit, you exit. So if you have a code that's actually unfinished within this flowchart, they will not be executed. So that's basically potentially it will hurt your application in some way, but that's your programmer. You decide when to use it appropriately. So let me actually take a look at another example. In this example, you can see that I have a 2 throw statement. I have a 2 catch clause. So I have a 2 throw statement, and the first throw statement to throw a string. The second throw statement, I'm throwing an integer. And I have a 2 catch clause. The first one is actually expecting an integer. The second one is expecting a string. So essentially, this is if you actually decide to throw a string, then essentially the transfer control would directly transfer to the second clause because it is actually expecting a string. And after you finish that, you actually go out. So okay, you are going to skip the rest of the code. You're not going to do anything for the first one. I mean, on the other hand, if you actually decide to actually invoke the second throw, the first throw for some reason you pass. You didn't have a null pointer, but you actually have the tag index negative problem. So you throw the tag index, which is actually catched by the first one, which now the parameter is the integer n, which is the information you would like to pass to the catch clause. So after you finish this one, you directly jump out to the same point. Okay, so that's basically the logical flow about how things are going. Okay, any question about this? Yeah.
Things you put in throw. What can you pass?
You can pass anything. Anything. That's a good question. Yeah, I mean, I thought because I saw all the example program, they're using a particular object from the exception class, and then but you can put your own class, which I will show you. Okay, all right. All right, so I'm actually going to I'm actually going to tell you another thing. So since I mentioned that what kind of things I can put into the as an argument for the exception for the catch, in C++, there is a standard exception, which is something which is convenient, is well designed, and over there it's called class exception. This one is actually STD, standard library, and this is the format. I just want to go over this a little bit. The format of this is that you have a bunch of what we call constructor, and then we have a destructor, and then we have something which is mandatory in every single class that's actually inheriting from exception is actually a function called what. So what is a function is actually going to return a message about what about this particular exception. So that's the format about this. And remember that this is a virtual. Why is virtual? Because I can inherit from this, and then so polymorphism essentially. So based on this, then this is the class hierarchy. This is a class hierarchy. You can see that, oh, wow, no, I don't want you to see this way. I want to move this way here. Now you can see the except. You see that the base is a class called STD exception. That was the one I just showed you on the left lower corner. And over here, there's a bunch of arrow class that was actually derived from the STD exception. So one of this, we actually already saw that, is called STD. Now I can go back to the bigger screen. The first one you actually see was bad type ID. That was the one I actually generated, because let me actually go back to the code. Let's take a look at the code. So remember that the relationship exception is the base. Bad type ID was the derived. Let's actually take a look at code itself, because you haven't seen the complete code. Let me do this. Okay, this is a code I show you. Let's see how I did this. I actually did a try. And then within here, I have this 6 line. I tried to print the type ID null pointer. That was an example I showed you earlier. But take a look at what I did here. I actually do this STD bad type ID. And I try to catch this. Okay, so let me actually show you what the output looks like again. Here. Okay, this is the output I got is NP derived and bad type ID. Okay, now I'm actually going to change this. Okay, I never done this, but it will be good to do a little bit experiment. So because I know that this is polymorphism and inheritance, so I can actually change this to exception. Okay, I changed this to exception. Let's see whether the compiler will complain. It didn't. That's good. That's what I expected. You generate exactly the same result. Okay, so you can see that I wrote it down as STD bad type, type ID, and then try to catch it. What's the disadvantage of doing this? The disadvantage is that what happened in the same block of code, I have actually other bad situation I would like to catch. You see that here I have a bad alloc, bad cast, bad type ID, bad exception, logic failure, and a bunch of things that's actually happened to your program, including the library. If I just say catch exception, then it's very convenient. I can actually catch anything, and they have a different what implementation. It's always polymorphic. As long as I get to the E, which is polymorphic, and then I just call the function, it will actually basically print me whatever I need to know. Okay, so that's actually the nice thing about using the standard STD class exception. Okay, any question? All right. So now I'm going to do a little bit like a bad alloc. Okay, I want to show you another example of a bad alloc. Let me see how much time. Wow. The most exciting part I haven't started. Okay. Let me show you the bad malloc first. Then we have to continue on Wednesday. All right, so let me tell you what I did with this program. So bat alloc is essentially I allocate a large integer array, with m size times m size, where I'm going to input m size. So if you actually allocate so much memory, your memory system within your program will realize you're used up all the available memory, and it's actually generate exception. And that exception is called bad alloc. Okay, so this is a program. Let me try to run it for you. So you can see that how I did this. I did a try and I catch it, right? And as I say I catch exception, which is the standard exception object, and try to do this. Let's see what happened. If I allocate an array is 20 by 20, no problem. I allocate m size is 20. I'm just allocate a 400, whatever, that's fine. If I allocate a few zeros, still no problem. My machine is big enough. You think I can still survive this number? No, it's not, okay? Because I'm allocating too much, you can see that I'm actually inside the exception, standard exception. Even though I'm a catch with exception, it is a bad alloc. But after I actually generate this bad alloc, you see that what I did here, this is actually trying to get the class name of that object. So let's actually go back to the code again. Look at what I did in the exception. I said inside the exception, standard exception. And the third line I did is type ID of the E, which is supposed to be exception, but because it's polymorphic, it's actually going down to the bad alloc. Okay, so that's the example that you can do. All right, so you can see that this table gives you a bunch of very useful tools that you can actually try different kinds of things to do that. Okay, so I have 5 minutes. I'm going to actually give you a interesting experiment, and then I will come back. Okay. Okay, let me show you this first. So you have you kind of get to know what I'm leading into. Okay, so I'm actually going to a program. I actually have a program called ecs36 exception. Make a mistake. I want no. Okay, inside you can see that I have a class I call ecs36b exception. And this time I'm doing multiple inheritance. I'm actually inheriting from std exception and then ecs36b special. Okay, that what is the special? The special is on top. So it's basically I just want to show I'm doing a multiple inheritance over exception. So I create a ecs36b exception. And just let you know that I'm actually doing in the GPSDD. I actually in the dump to JSON, I play a little bit trick. I said what? The first line you can see that I actually create an exception called ecs36b exception. I call them my exception. And then I check the latitude, whether it's out of range. So latitude, longitude has to be within 90 to minus 90, 180 to minus 80. If the range is out of range, I'm actually going to throw my exception. Okay, that's what I'm doing. I create my own exception, and I actually try to do that. And then in my function, Finally, I go to mobility dump.cpp. At the end of the code, take a look at what I did. I did this, I create a GPS DD 00, that should be fine, but I create another GPS DD, which is 9.1000, means out of range. And then I basically call dump to JSON. When I call dump to JSON, I actually try to catch exception, and it's supposed to actually be able to catch, right? Okay, so I'm going to run this program. Let's see what happened. Okay, this is actually a really fun experiment. I hope you can actually do something yourself. Let me actually run the server. And I'm going to run mobility dump. Okay, you see that? It's actually print out ecs36b. Why is that? That was the error message. That was the exception handling routine that I generate. Let me show you where I did this. Yes, this should be this one. Why it generate this one is because over here in my ecs36b, you see that my what? Remember, that was the message. That was a function I must have. And what's in the what is return ecs36b. Okay, that is only, so it works. I create my own class and then do something looks like that. Okay, great. Okay, now I'm going to change this code a little bit. Okay, I'm actually going to get rid of this line. I'm actually going to replace with this line. What's the difference? Let me take a look. What's the difference between the first line and the third line? What's the difference between the first line and the third line? Yes. Did I use virtual? Oh, okay, sorry. Thank you. I want to get rid of virtual. Like this. Like this. Okay, so it's actually, what's the difference between this line and this line? Now? The order they swap, right? Do you, as a programmer, do you expect the program to behave the same? We should, right? Let's see what happened. Compile. Let's try to run this. Try to run this. What message you got? Now I'm not getting ecs36b. I'm actually getting was terminating due to uncaught exception of type, ecs36b exception. And the board tracks 6. That's actually very dangerous. We're doing multiple inheritance. Did I ever tell you that I don't like multiple inheritance very much at this moment? Okay, so you switch the order, it didn't work. Okay, so now I tell you how to get it to work. If you really want that order, you add a virtual. If you add a virtual in front of here. If you don't want virtual, fine. You have to follow the order. If you want that multiple inheritance, you add this virtual in front of this. It's the same order. Then the second one. Still? All right. Oh, we'll talk about that next time. Okay. But just switching the order is not good. All right. Sure. Give me 1 second. I want to turn off the